Hi, and welcome to this Telit Cinterion webinar, Industrial AI, Transformers Power Smart Manufacturing. I'm Amanda Flink, the head of global events here at Telit Cinterion, and I will be moderating today's event. To present this topic today, I am pleased to be joined by Lanier Zamir, our lead of AI development at Telit Cinterion. Hi, Lanier.
Hello, thank you.
Now, just before I hand it over to you to start our presentation, I just want to remind our audience about a few things. We will have time to answer some questions at the end of our presentation here. You can simply submit a question by posting in the questions box, which should be located near the bottom of your screen. Also, please be sure to check out the resources section for some additional information. There you can find today's slide deck and a few other resources about our topic. And finally, we will send out a replay link to all attendees at the conclusion of the webinar in case you miss any and want to go back. And with that, Lanier, I will hand it to you to kick us off today.
Thank you so much. I can just share. All right. Yeah, thanks again. So I'm going to be presenting the industrial AI transformers and how we can use them in manufacturing. Like Amanda mentioned, I'm the lead of AI development here in Telit Cinterion. And what I'll be covering today, I'll go a few topics. First of all, we're going to talk high-level concepts about industrial AI. Then dive into the AI in manufacturing, how it can be used for improved manufacturing. And then we're going to talk about the transformers themselves, what it means. We're going to break down the transformers, how it can be used in industrial AI, some core capabilities, and then explain a little bit more about deviceWISE AI, which is another layer that we have on top of deviceWISE. And at the end, I'm going to talk just about the future, some of the trends that we can see in the future, and the conclusions. I'm going to close it off. So speaking about industrial, in the past couple of years, we've started to see there was a new revolution in the industrial AI, which is called Industrial 4.0. We've seen some changes from the old fashion, from the old ways of how just stupid robots communicating with each other. Now we see there is a lot more of technology involved, IoT, a lot of AI, a lot of big data to turn the manufacturing into a much more automated system. And we see also the smart factories, which basically integrates AI tools into the day-to-day manufacturing to make robots communicate with each other, having some real-time decision-making and more. The key component that we see in the industrial AI, first of all, is the interconnectivity, where machines nowadays can talk to each other, they can communicate, they can share data between each other, some real-time data as well. Everything on the floor, on the factory floor in manufacturers, can either be stored on a cloud, on a local server, and the data, there's a lot of data coming through. And of course, the automation and AI, as mentioned before, basically making the whole process much more intelligent, autonomous in some ways. And there is, of course, impact on the productivity of the manufacturers, enhanced production flexibility. Now factories can produce many different parts at different times, reducing the operational downtime through predictive insights, which, again, AI plays a huge role specifically in that sector. And of course, high productivity and reduced operating costs, because now we can be much more focused. We can reduce downtime of machine. We can enhance productivity. And overall, this 4.0, the industry 4.0, makes the whole process much more intelligent. So the role of IIoT in manufacturing. So what is IIoT? It stands for Industrial IoT, or Internet of Things. Now, because we have so many data coming through all of the different sensors that we have, all the different PLCs, robots, the factory becomes much more heavy in terms of data. So sensors continuously monitor equipment performance, operating conditions, and production quality. We have all this data. And as mentioned before, we also have the connectivity and the integration, which seamlessly connects factory equipments to devices to cloud platforms and software systems. So again, we have much more data now can be stored locally or on the cloud. And how IIoT enables AI? So AI essentially is a lot of statistical models, a lot of data. It requires so much data to train models, to use the different models. So because we have all this data on the factory, it's such an important base to allow the AI to function. So it generates high quality, extensive data crucial for AI-driven analysis or analytics. It provides a foundation for AI models to perform predictive analytics, anomaly detection, and process optimization, which we'll talk a little bit about what it means, each one of these topics. And of course, we have the deviceWISE AI, which is another layer on deviceWISE that allows, of course, integration with AI. And it simplifies the integration between machines, cloud systems, and AI models, which again, we'll talk a little bit more in the next couple of slides. So AI in manufacturing. First of all, why even considering using AI in manufacturing processes? And of course, the answer is pretty obvious for given three main reasons, but there's plenty more and sub reasons within these reasons. So first, predictive maintenance. In factory, every machine has some lifespan and it operates differently under different conditions. So be able to predict when a maintenance should be scheduled is a huge benefit for factories. So AI proactively anticipates equipment issues, saving costs and unexpected downtime. We have real-time quality control, which this one is a lot of computer vision involved, having cameras on a factory line that can look at a part and immediately tells if there is an issue, if there's an anomaly on the part, if the production is not running as expected. So AI-driven visual systems detect defects instantly, improving product quality and minimizing waste. And we're talking about operational optimization, which on the high level factory has so many components to it, and everything needs to work in a certain flow. Now, sometimes there can be parts of the flow that are not working as expected, meaning that maybe the temperature or the power consumption at a certain time is too high or higher than average. So AI can predict those or can detect and offer suggestion of what to do and how to handle the flow to make it much more efficient. So as it says, AI analysis analyzes vast data to streamline scheduling, energy use, inventory management as well, and resource allocation. Again, making the factory much, much more efficient. So some of the challenges that traditional AI faces, given what we just talked, is the complexity in managing large data sets generated by manufacturing sensors. There's so many different sensors, so many different types of them, and so much data coming through in different languages, in different ways, different protocols. So this is one challenge that we see with the traditional AI. And also, there's a need for a fast and scalable AI models. So these two issues prove to us that traditional AI, as much as it's great what we currently have in manufacturers, but we need to have something more robust, something better than the traditional. And that's where transformers comes into play. So transformers is the game changers in AI. So what exactly are they? Transformers are essentially an AI model that is known for their ability to quickly analyze large amount of data and find patterns. It has a very sophisticated mechanism that I'll dive into in the next couple of slides, where it can detect the context of the data. It can understand it. It can learn from it and learn how to operate better based on the different patterns that it sees on the data. Originally famous is for powering the applications like ChatGPT. I'm sure you've probably heard of ChatGPT before. GPT stands for computational comprehensive. I forgot. Generative pre-trained transformers. That's it. And the T stands for transformers. So the transformers is basically the building blocks of so many AI tools that we see nowadays, starting, of course, with ChatGPT, and all the different LLMs are based off transformers. But we saw recently that we can take the same technology, and instead of using it only for LLMs, it can be used for so many different aspects, so many different usages. And one of them, of course, is the factory. Transformers have evolved beyond chatbots, as mentioned, and now revolutionize industries by making sense of complex data in real time. Some of the key features of transformers is they understand context and relationship between different data points. So it doesn't need to be the same type of data, but still it can make these connections. They learn quickly, adapting to new scenarios without being explicitly reprogrammed. So there's no need to always update the model. And you'll see in the next couple of slides again how exactly does it do it. But essentially, you can think of it as a way to rapidly reading millions of pages, instantly finding key insights, and using those insights to make smart decisions in seconds, even faster than that. Let me just make my screen a little bit bigger. Why do transformers matter for industrial data? So we talked about transformers, and we talked about some industrial, the revolution, industrial revolution 4.0. So why do transformers matter for that? So of course, transformers analyze vast sensor data from machinery, detecting anomalies and potential problems faster than even before. So we see this improvement in the time that these models can now learn from the factory floor. They instantly understand complex patterns in machine performance data, operational logs, and visual inspection. They can be implemented in all the different, the spectrum of AI that we have on the factory floor. And some real-world industrial applications. So there is a rapid contextual understanding, regardless of how the data is being sent, the transformer can learn and, again, learn the patterns of the data, regardless of how it reads it. So it can be sensor A has sends data in a certain way, and sensor B sends it in a different way. It doesn't actually matter for the transformer. It would still be able to learn and to learn the connection that they might have between those two sensors. Real-time pattern detection. Again, it can very fast and instantaneously detect the different patterns of a given data. And minimal retraining needed because it's so vast and broad in its learning capabilities. You don't need to retrain it on new data, on new sensors, on new information that is arriving to the transformer. And of course, the business impact is less downtime, fewer defects, lower operational costs, easier, quick decision making for engineers and managers. Basically, it's great. Let's see. So how do they work? We're going to take a closer look at them. It's going to be maybe a little bit technical, but I'll still make it, I hope, in a way that is understandable for everybody. So as a very high level, and I'm going to probably go through these several slides, we have two key processes for transformers. One is the encoding, as the other one is decoding. These are the two keywords of transformers. So encoding is basically understanding the data to be able to get information. It can be all the data. It can be text format. It can be image, logs, and then it can learn and understand patterns and context. That's the encoding. The decoding part, it uses patterns to produce relevant and useful outputs like different predictions, alerts, recommended actions, and so on. This is the decoding aspect of it. Now, transformer doesn't have to have both. You can have transformers with only encoding or only decoding, or have both in a single transformer. For example, ChatGPT, by the way, it's only decoding. I know it sounds not intuitive, but you're asking, wait, how does it know? It doesn't actually learn the data using encoding, but it does. Is able to do it using decoding as well. I'm not going to get into it, but there can be multiple ways of transformers. Why are they different? So transformers handle large amount of data in parallel, greatly improving speed and accuracy. So if you can see on the right side, there's these graphs, and you see a multi-head attention, it's called. Basically, it's running parallel processing on any single data that it gets. So it can do it very, very fast. Transformers have a built-in mechanism called self-attention, which helps focus only on important parts of the data, ignoring irrelevant information. Very sophisticated, very useful for any type of data processing. And for example, prediction of machine failure, transformer-based AI system analyze sensor data from equipment and immediately noticing subtle signs of trouble. For example, there's unusual vibration or unusual heat or temperature that it sees, and then based on that, which was the encoding part of the process, it can then generate an actionable insight, such as, machine this and that is likely to fail in the next 12 hours due to the reasons that it learned. So it's a very sophisticated system that can learn the data, see the patterns, and provide some suggestions. And break it down a little bit further. There are 4 different actions or parts of the transformers. Again, briefly on each one of those, and essentially I hope it's going to make sense. So first, when a transformers sees data, first thing it does is tokenizing the data. Tokenizing, what it means basically is it splits the input data, usually the text, into a smaller units called tokens. That's all. Just look at the example. There's transformers are powerful, for example, so it breaks it down into each word. Now, in real life, it doesn't actually per word, because some words can be longer, some shorter. So there's a fixed amount of data that it takes per token, but the idea is the same. It basically breaks down this huge data. In this case, it's a single sentence, but it can be thousands of pages, and it breaks them down into those tokens. And once it does this, the next step is embedding. Embedding, this is a whole world, and this is, I can dive talking only about embedding for the next hour or so. So I'm just going to give a high-level idea, but embedding is basically converting those tokens into numerical values or vectors. And these vectors are basically lists of number that represent their meaning, their value in a high-dimensional space. So basically, you can think about it. Each token gets number assigned some number values to it. And what's interesting is that it can assign similar values to similar words. In this case, you see we have king and queen in the example. It doesn't make sense for us as human, but for machines or for the transformers, it can see that there's similarity between those 2 words, because the numerical values are similar in some ways in the vector spectrum of multidimensional space. For example, if we had to add another word to it, let's say bicycle, it would be a completely different numerical value. So that's how we would know that this is not the same as the relationship that it has between king and queen. And third process is the self-attention, which basically, once we broke down these data into tokens, then we vectorized it. So the next step is to find relations and to find the importance of each one of these words or tokens. Self-attention is a mechanism that lets the model focus on relationship between tokens in a sequence, weighting their importance dynamically. There's different ways to achieve it. For the example I can just give you to make it pretty intuitive, is you can think about how many times a word repeated or a token repeated itself in the data. The more it repeated itself, it would be probably more important. That's not exactly how it works, but that's an easy way to understand a similar action that it does for the self-attention. And then each token gets 3 vectors, Q, K, and V. Not going to get into it, but just high level. Q is finding the proper value that it's looking for. K is comparing the vector, the value that it has with another one, and the value is the value itself. Doesn't matter, it's not that important, but at the end of the day, it's good to understand that it knows to weigh those different tokens and find the ones that are more relevant. And the fourth and last is the classification. Classification is the final step where the model uses its contextual understanding to predict an output like label or category. For example, let's say I want to find if a machine is good or bad. So I have 2 categories, good or bad. So based on this data and based on the data input, it would know to categorize the different data sets that it has, if it's good or if it's bad, based on the data that it sees. And why it's important, it turns the model's insight into practical results, such as identifying sentiment or answering questions. You can see it in the example, the good product gets a 95% probability of being a positive statement. Very basic example, but you can think about the use case to be much more broad than this. So I hope it kind of makes sense, and how they work together. This is one step at a time. So first, it tokenized the information, like I said, the data, chops the input into tokens, then it's embedded, or embedding meaning turning the tokens into a numerical value or vectors, and then self-attention, it uncovers relationship between the tokens, and finally it classifies and can predict the output based on the data that it received. So now that we know a little bit more about transformers, how can we use those in industrial AI? So, of course, four of the main use cases we can use in transformers is predictive maintenance. There is so much data coming through, so we can very easily use this data and fit it into a transformer, and for it to then see what can fail, what can predict different outcomes of different machines based on the data. Automated service scheduling, it can see that in a few months or some period of time, there's going to be a maintenance, so it can schedule that as well. Quality control, anomaly detection, either on data or images. It can see anomalies in image without prior training. So if there's a scratch on a part, you don't need to tell it what a scratch is. It would know based on its reasoning. Production optimization, we're talking about throughput and bottlenecks analysis, sees all the factory floor, can find areas to improve. Adaptive process control, and of course demand forecasting and supply chain. If there's a high demand of some products, it can learn that and can recommend what to do in the near future. Responsive inventory management, and so many other things that we see now. The factories can be so much more intelligent, so much more complete using this technology, the transformers technology. And again, just key benefits, similar to what we said before. There's the contextual understanding, so it can consider entire data sequences for anomaly detection or classification. It can capture the long-range dependencies. It can see, for example, if you have a spectrum, not a spectrum, sorry, a long period of time of data, it can find the different trends. Again, without teaching it too much, you can fine-tune some transformers, but essentially, it can learn by itself and find those different trends within a data set. Real-time pattern detection, we talked about the anomaly detection. Parallel processing enables near instant insights, very, very fast instant alerts. Adaptive learning, there's a low overhead for model updates, meaning if you need to update your data or if you update your sensors, so there's a new data coming in a different format, you don't necessarily need to retrain the transformer because it's smart enough to be able to kind of adjust itself and learn as the more data comes into it. And versatile data handling, because again, there's text, image, timestamp, logs, and all different data types the transformer can actually read and understand. So speaking about deviceWISE and deviceWISE AI. So deviceWISE AI allows integration of transformers, and we are using a lot with NVIDIA tools. NVIDIA NIMs is kind of the top ones that we're using, which is the inferencing microservices. And basically, they allow us to run AI model in a very optimized fashion on some NVIDIA hardware. We deploy those models, the transformers, on the edge using either Jetson or on some cloud service. Again, it depends on how the factory want to handle their data. Some of them want it on the factory on premises. Some of them don't care, so they want more powerful processing, so they put it on the cloud. And some of the key features that deviceWISE AI provides is protocol agnostic connectivity. We have drivers for so many different PLCs, robots, tools in the factories, and the transformer can see all this data coming from the tunnel of deviceWISE and basically analysis all of that information through this protocol agnostic connectivity. deviceWISE offers edge and cloud deployment. And of course, we're talking about scalable architecture. You can deploy it on as many factory floors or many assembly lines that you have in a factory. And at the end of the day, this is deviceWISE AI, or deviceWISE in general, is an industrial IoT platform that provides out-of-the-box connectivity to shop floor equipment, sensors, and enterprise systems. Basically, this is a one solution to fit them all. Why integrate even transformers with deviceWISE? And because deviceWISE is such a comprehensive solution that all this data. So first is the efficient data pipeline. deviceWISE talks to so many different parts, and gathering all of them through the pipeline of deviceWISE allows the transformers to have access to all the information, reduce operational complexity. Um, there's a no-code environment that deviceWISE has or offers, that there's no need to know AI, there's no need to know coding, and using this deviceWISE and the integration of transformers with this is a very simple and minimum complexity process to actually implement this solution into any factory floor. Connectivity and data normalization, again, because deviceWISE talks to everything in its own, and it can basically normalize all the data that it comes to make it easier for the transformers to be able to enhance the ability to learn and to predict anything, basically giving this data. Of course, an edge deployment and latency reduction is pretty clear. We can deploy those transformers and the deviceWISE locally or on the cloud. And easier models lifecycle management. deviceWISE handles everything about the transformers, can replace the model if needed be, and can do all these basically maintenance, the model maintenance, we'll call it, automatically without any need for a user to again, know AI or know coding and so on. So just to give a high-level architecture of the deviceWISE AI. So there's the data acquisition, which it talks to basically any type of PLC, any type of sensor, any type of industrial device that you might have on the factory floor. So the sensors and PLCs, it can talk to any type of device that you have on the factory floor. Uses any type of protocol, because again, through the tunnel of deviceWISE, regardless if you're using OPC UA, MQTT, Modbus, whatever, deviceWISE can translate it directly into the transformer. And then the data pre-processing, if needed be, if there's a need for human interaction to clean the data, to normalize it, so it can handle all of it, and building an unified data stream for AI inputs. So again, because there's so much data going through deviceWISE, and it's so easy for it to then push it onto the transformer model. And it does the inference by itself. So this connection, deviceWISE can talk to any transformer model, providing a real-time prediction or batch scoring, depending on the use case. And then, of course, it provides an actionable insights with the response, with the decoding of the transformer. It can then provide an actionable insight to the user, what to do, how to recommend stuff. And also, I didn't mention that, but it can also, transformer can be used for documentation, for example. So if there's a bunch of text data, so that you either want to teach an operator or how to use deviceWISE, or how to use whatever machinery that you have in the factory, so it can use transformer to basically using an LLM, a very natural language, type in, what do I do in case this and that? And it would know to search through the entire documentation and provide the proper solution, the proper example to the person asking. So we have all of these different capabilities under the umbrella of deviceWISE transformers. So some of the future trends that we see in the industrial AI. First, we see many companies are now trying to make edge transformers much more accessible, because transformers inherently they require a pretty heavy equipment, a pretty heavy NVIDIA, or it doesn't have to be, but it needs to be a powerful device. So now we see more and more companies trying to find or develop an edge component hardware that can support transformers on it. This is one thing very interesting to see at the development, especially in the past year or so. Multi-model models, we're talking about models that can work with images as well as text, as well as whatever data type you throw at it, PDFs, anything. So if you have a single model that can handle all these different models, it's easy. It makes life easier for basically everybody. Federated learning. A lot of the data that is on the factory, it can be sensitive data. So instead of throwing all of this data into a transformer, you can choose few data points from here, a few data points from there. Maybe a different factory has a different data points you can throw, and all of this data goes into a single a training model for the transformer, and it would know to then kind of combine all these different inputs and have this federated learning. Much more, of course, speed and security involved in the federated. And then natural language interfaces, similar to what I explained before about the documentation. A user can type in or say talk. Nowadays, there's also agents that can translate voice to text. So you can speak or type any request that you have from the factory. Basically, you can say, show me the temperature of this and that, or turn the robot on, turn the lights on, call maintenance when you see this and that. So all of these natural language interfaces are becoming much more popular. And this goes hand in hand with what deviceWISE offers, deviceWISE AI, which has the industrial copilot as well, which allows users to interact in a very natural language. Instead of talking machinery, we don't speak machinery. We don't know ones and zeros. We do speak language. So it's easier for us to have actions using our words and stuff that we can actually understand instead of writing codes or anything like that. So we see a big jump in the natural language interfaces as well. Yeah, so that's the future. Now, conclusion of, I know we talked a lot for the last 30 minutes. But transformers, as mentioned before, this is definitely a shift in the industrial AI, shift in AI in general. We see the usage of transformers, again, almost everywhere in any industry, from ChatGPT to aviation to manufacturing, and so many different use cases for that. The device-wise, definitely the enabler of implementing transformers in manufacturing, again, because of the huge data amount that device-wise handles on every second, basically, and the complexity of data, and the fact that device-wise can then normalize all this data and make it much more easy for transformers to learn and work with. And some of the key takeaways from this lecture, basically, or the transformers, is the key time insights. Combining transformers architectures with device-wise, it helps to quick detection and of defects and failures. It allows scalable deployment. Device-wise plug-and-play connectivity makes scaling from pilot to enterprise-level deployment straightforward. And of course, continuous improvement. There's always more data coming into the transformers, and retraining the transformer models. It allows the whole process of retraining and adding more data to it much more easy. And we talked just a little bit what the future holds, but a few more words on that. So we talked about the edge and now hybrid AI. Expect continued miniaturization and optimization of transformers for on-site and hybrid deployment, meaning we try to make the transformers much more small to be able to deploy on edge devices that might not be as powerful as cloud devices. Multi-model and federated approach, and Industry 4.0 evolution. Advanced AI adaptation is key to staying competitive in rapidly evolving manufacturing ecosystem, and that's why we're trying to be one step ahead. Embrace the synergy of powerful transformers-based analytics and flexible industrial-grade platforms like device-wise. So that's it. It definitely just finish it by starting small and scaling through thoughtfully. You can transform your manufacturing process, reduce downtime, and drive significant ROI. So again, making these transformers is a very almost intuitive tool for device-wise to allow the manufacturing and the productivity, where basically the sky's the limit. Yeah, so that's it for these slides. So I hope it made a little bit more sense now, and that you understand more about transformers when you hear that that word in the future, and not just the movie. I'm not talking about Transformers the movie, but yeah. Thank you.
Thanks so much, Linear. Audience, real quick before we get to any questions, I am going to drop a poll on your screen here. If you would like to have somebody contact you directly, please just respond here on the poll and we will have somebody reach out. We do have time for a few questions, and there is still time to ask a question, so please feel free to submit using that box on your screen. Linear, we've got just a couple.
Sure.
We can go through these. The first one I have here says, how do transformer-based AI models differ from traditional machine learning and industrial automation? And also, what advantages would they bring to my manufacturing operations?
Yeah, so good question. So we talked a little bit about the old AI. So you can think of transformers as a much more sophisticated and intelligent way to handle a large amount of data. Up until now, when you had so much data coming into from the factory floor, it used different protocols. The data was sparse. It was different. One sensor gave you data using some type of protocol. The other gave you a different one. So to be able to use the old AI, I'll call it old AI. It's not that old, but I'll call it the old tradition AI. You would need to basically understand all this data and either transform the data yourself and make it understandable for the AI, or just use the same sensors and use the same environment to be able to actually teach the AI. Now, the Transformers AI, it doesn't require you to process the data. It would know, just throw as much data as you possibly can on it, and it would just know to go and compare the different data types, find the patterns between the different data types. So basically, it has more of a contextual data understanding, unlike the traditional AI, the old AI, which it basically looks for numerical values and does like a very cold comparison. If it's above this number, it does this. If it's below, it does that. So the transformers allow a much more comprehensive and a much more easy to handle solution. And again, we're talking about time. Instead of, if there's a change in the production, instead of retraining the model, because that's what you would need to do in the traditional AI. If there's a new data coming in from a different source or from it uses a different protocol, you would need to retrain, and this can cost a lot of money, a lot of time, which can lead to downtime. So instead of having all that, transformers can automatically understand the new data, and it doesn't require you to retrain the model. So all of this basically allows your solution, the factory, to be much more efficient at the end of the day, because you don't need to readjust the models. It's very flexible. It's very scalable. Transformers, you can have so much data coming in from different sources, as mentioned. So yeah, so that's.
Yep, great explanation there. Next question I've got, how do transformer models enhance human-machine interactions, specifically in manufacturing?
Yeah. So for human machines, it's funny, but it's the same as what I said before, that we don't speak robotics. So for a person to be able to control a robot by typing or saying, I wanted to do this, I wanted to do that, it makes, first of all, it makes it easier to understand what's happening. And also, if there's an anomaly and if there's any issue, instead of you needing a data analytics to look at the data or the results and say, oh, because of this, you would need to change the temperature of something. So instead of having someone to look and then try to figure out and analyze, it does it by itself. It can learn the patterns. It then can make a prediction, and it can present that prediction in a very intuitive way that any person can understand. It can tell you exactly what to do in a natural language, even kind of a way, what to do and how to do it, making life definitely much easier. And speaking as well on documentation, be able to access documentation, be able to train operators on the factory floor instead of relying on old system, or if there's a question, the operator has a question, instead of needed to search through documentation or going to someone and spend so much time just understanding a basic concept. It can just use the transformers to quickly learn and diagnostic using all the documentation and logs. So yeah, it definitely makes life easier for every person on the factory floor, making it much more approachable as a human.
Yeah, great. And time is money, as we all we all know, right? Let's take just one more question here. Can you give some examples of the top use cases of transformer-based AI?
Yeah, similar. Yeah, so similar to what we discussed. So we have first and foremost, I would say, the predictive maintenance that we have on a factory floor, learning from different equipment and be able to get some information on when it's time to replace a part. And also very important that we saw in different manufacturers, they want to know what can happen if I replace a part. So instead of, let's say there's a part that costs $2 million. So instead of buying this robot, for example, they can use the data, and maybe there's a data that they can have from elsewhere that robot is working with. And you can take those two data and feed them into the transformer, and it would then know to predict how the manufacturer is going to go with this new robot, with this new piece. And maybe it can tell you, hey, with the current power consumption that you have in the factory, you can't actually do that, which that's such a benefit, or it's a huge thing to know, instead of actually buying this $2 million robot and then put it in a factory and all of a sudden, hey, it's not working. So it can predict those different components, and it can give you insights on the flow of the factory. And we're talking about the quality control, using cameras and feed them into what is called the VLM, which is a visual language model that is again based on visual transformers. And you can feed images to it, and it can tell you, without needing to train a model, you can just send an image to a VLM, and it would tell you, hey, there's a scratch on it. And again, this is huge because up until today, you had to teach a model, an AI model, what a scratch looked like, or what the piece looks like without a scratch, for it to actually learn and understand it. So now the fact that you can have this as a zero shot, you don't need to train it, you just feed the image into a transformer, and it automatically can tell you if there's an issue on it or not. This is massive as well. Again, time and cost. We talked about process optimization. The flow of the factory can tell you if something is not right with the power consumption, the temperature, or anything that you have that running on the factory. And yeah, I think that's pretty much it.
Yeah, I think that's a great place to start. It will be so interesting, I think, to see how this continues to transform business. Audience, I believe that's all the time we've got for today. If I did not get to your question, we will be sure to review those and have somebody reach out. Please check your inboxes in the coming days for that replay link. Again, there are additional resources in the resources section here. Lanier, thank you so much for your time today. Really appreciate it.
Of course.
Yep. Have a good one, guys.